uh, here they say a quantity is either scalar or a vector. Which row of the table is correct? Here we have scalars over here, and here we have vectors. Okay, let's check first one. Energy is a scalar, momentum is a vector, so the answer should be part A. I'm going to check B, C and D also. Displacement is a vector, not a scalar, so it is wrong. The acceleration is a vector. Time is a scalar, correct, and mass is also a scalar, not a vector, so this is should be a scalar. And velocity is a vector, not a scalar. Force is a vector, it's correct, so the answer is A. I just randomly checked these three, right? Which of the following is an SI unit for momentum? The equation for momentum is P equals mv, and the SI unit for mass is kilograms, and SI unit for velocity is meters per second. So the SI unit for momentum is kgms minus 1, so the answer is A, right? In the third one, here they're asking which of the following could be used to describe the elastic limit of a material, right? I hope you remember this graph, stress versus strain. Here we have stress and here we have strain, and the graph looks like here. This should be right. It's little ugly. It's okay, I want to explain these 3 points. Right, here we have the A over here, and here we have B, and here we have C. What is A? A is the limit of proportionality, right? We call it limit of proportionality, right? If our stress and strain is beyond this limit of proportionality, it does obey what? Hooke's law, right? Force is directly proportional to what? Extension, right? It does obey Hooke's law. And after this point A, limit of proportionality, this does not obey Hooke's law. So what is then B? B is limit of elasticity. Elasticity. I'm not sure whether it is SOC, but it is elasticity. I know you know what I'm going to explain over here. Elasticity. Then after point A, still our material will deform elastically, not plastically, right? Deformation can be happen in 2 ways. One is plastically, another one is elastically, right? So in here they are asking which of the following could be used to describe the elastic limit of a material. In the first one they say the stress above which the material will not obey Hooke's law. So right here they say the above B, what? Material will not obey Hooke's law, but we all know after A, after limit of proportionality, it does not obey Hooke's law. It does obey Hooke's law if our stress and strain are in beyond this point A, right? Then the second one, the stress, so this is wrong, right? The stress above which the material will be deformed when the stress is removed, right? The stress above which the material will deform when the stress is removed, that is correct, right? Until limit of elasticity, our material will come to its original shape if we remove the force, or we call it stress, right? So the answer should be B, right? After B, which we call limit of elasticity, the object will deform plastically, so it will not come back to its original shape, right? C we call yield point, right? We call it yield point, and at that point what happened, right? The atomic structure is rearranging and it will undergo a very high increase in extension, right? So the answer is B. Here they say a ball falls through air from rest. Which of the following shows the graph of displacement against time for the ball? Here you can see all of these graphs represent negative displacement, right? Our displacement is increasing negatively. Over here it is constant, but it has a negative value, right? And we are our ball is falls through air from rest. How is it possible, right? Here's our ground and here's our ball, and we should measure our displacement from ground to ball, right? Then what will happen? While this ball is moving towards ground, our displacement will decrease, right? And our direction of displacement is opposite to the direction of the motion of the ball, so this will have a negative value. If we have taken this one positive, this one will have a negative. Displacement will have a negative value. So while this ball is moving down towards ground, what will happen? Its velocity will increase. It means the velocity will increase. It means the gradient of the displacement versus time graph will increase, right? Negatively increase. Why? The gradient of a displacement time graph gives us velocity. If velocity is increasing while ball moving towards ground, the gradient of the graph should be increased. Over here it is constant, right? It is 0. Over here it is 0. Gradient is 0. Over here the gradient is constant, and over here the gradient is decreasing, right? And over here it is increasing. So the answer should be C. Right. Here there is a fifth one. A helicopter moves vertically upwards with an increasing speed. Which of the following describes the increase in gravitational potential energy of the helicopter? Right, here is our helicopter, right, and it says that it is moving upward with increasing speed. It means it is accelerating, right? It is accelerating, and you should know that the helicopter is supplying, or it is the source of energy, and it is giving its energy to two operations. One for this acceleration, right? For this acceleration. Other one is change in GPE, right? It is change in GPE. It has to increase its gravitational potential energy while it is moving upward, right? And it is accelerating, so it should provide its energy to these two operations, right? Okay. And here they say, which of the following, they're asking which of the following describes the increase in gravitational potential energy of the helicopter. Okay, first sentence say the work done on the helicopter by the force of gravity, right? It is wrong. We don't need to care about this one, because there is no work done on the helicopter by the force of gravity, right? If helicopter is moving down like this, like free fall, then there will be a work done on the helicopter by the force of gravity. Now helicopter is doing work against the force of gravity right now. So B, it says the total work done by the helicopter as it moves upwards. This is also wrong. As I told you, right, the total work done by the helicopter is giving its energy to two operations. One is changing GPE, another one is acceleration, right? Third one, the work done by the helicopter against the force of gravity. This is the one we are talking about, right? That will help, or that will give its energy to change its gravitational potential energy. And D, it says the work done by the helicopter to increase its speed. That is the energy source or energy portion required for accelerating, or which we call increasing speed. So the answer is C. Right. Here the sixth one, they say velocity, an object moves with velocity v, the kinetic energy of the object is doubled. Which of the following is an expression for the new velocity of the object? Right, we all know what is directly proportional to v square. How do we know this one? Because kinetic energy is equal to half mv square. These half and m are constants, so we can write it like this. So if we double this one to e, we will have new speed square, we can call it velocity. If this one is 1 and this one is 2, if I divide this 1 and 2, I will get e over 2e equals v square over vn square. So if I subject this vn square right here, this is vn square. So if I subject it, it is equal to, it is half 2 times v square. So I need to take the square root of 2, then vn equals to root 2 times v. So the answer is A, right? Then seventh one, right? Here they say a power station provides an electrical output power of 2.1 gigawatts. The power station transfers thermal energy to the surroundings at a rate of 3.4 gigawatts, right? They're asking the efficiency. Efficiency is equal to what? Useful energy output, or we call it energy or power. Here they have given the power, right, not the energy. The reason is they here, look at, you can here look at, it's gigawatts, what means the unit we use to measure power. So useful power output over total power input, right? So this is what we call efficiency, and useful power output is what? 2.1 gigawatt, 2.1. So total power input is what? 2.1 plus here, right, transfers thermal energy to the surroundings at a rate of 3.4. So both of this are the total power input. So this is the answer. A is the answer, right? Okay, eighth one. Here student applied a tensile force from metal wire of length x and diameter d. The length of the wire increased by delta x. The student applied the same force, right? Keep in your mind what? The same force to second wire made from the same material, which means same Young modulus, right? The length, the wire increased delta to delta x, right? Okay, if we wrote the equation, right, for Young modulus, it is E equals F over A times x over delta x, right? So A is equal to pi r square, and we all know r is equal to d over 2, because they have given discussion in terms of diameter, not from radius. So we need to plug diameter into this equation, right? Okay, if I plug it for A, it will be A is equal to pi r square, right? If I square this 2, I will get d square over 4. So here it is d square over 4. Now I'm going to plug this one into our equation. E is equal to F over pi d square over 4 x over delta x. If I rearrange this one, E equals 4 over pi, here it is f o, I'm going to take f to this side, because here we don't change the force and the Young modulus, same material. So I'm going to take it over here, f to here, right, by cross multiplication. Here it is 4 over 4 goes to numerator to the top. So it is x over d square 1 over delta x, right? Okay, right? This is the common equation for both of the wires. Now we have to find what if the second wire has increase in length, right? We call it extension is 2 delta x. They're asking what is the length and diameter of the second wire, right? For both of these wires you can clearly see that E and F are constants, which means our left hand side of the equation is constant for both of these wires, right? Then if this one is constant, right, it does not change for both of the wires. It does not change for both of the wires because E is constant and F is also constant. That means this side also should be what? A constant, right? That's the only possible way that we can balance this equation. If this is constant, which means if it is not changing, this side also should stay as constant. So here they say the delta x has double, so we have 2 at the bottom, right? To make this right hand side balance, we should have 2 on the top also. Why? Otherwise our equation will not balance, because this side stay as a constant. E and F is constant, so 4/5 is constant, so we cannot change this one, and the only possible way is x over d square. So our x over d square plus produce x over d square should produce this 2, right? X over d square should produce this 2 over here. So x over d square should be equal to 2. The ratio should be equal to 2, right? I hope you got this idea. I will explain it again if you want, or you can skip this part if you got the idea, right? And we have 2 wires over here, right? We have 2 wires, and this is the common equation for both of these wires, and they say they don't change the force and the same material, right? I have I have taken this E and F to one side, and if they don't change, if they did not change, what? E and F, right? Our left hand side of the equation should remain as a constant, so it is remaining as a constant. So if it is remaining as a constant, right, to balance this equation, this side also should be a constant, right? But they say what? Delta x has increased by 2, which means we have 2 on the bottom, right? To balance this equation, we should have 2 on the top. So how is it possible to have 2 on the top? 4/pi is constant, so they are not changing, they are constant, right? Only possible way is x over d square ratio should given us 2. So x over d square should be 2. So if you plug these values, right, obviously if you plug this one, you can have 2, right? 0.5 over 0.5 square, which means 1 over 0.5, right? So the answer is A. So if you want to plug it, you can plug it. 0.5x over d square means 0.5 d square, so you will get 2. The ratio x over d square ratio is 2, so the answer is A, right? Here in the 9th one, a box of weight W is suspended in equilibrium from a support by 2 ropes. The tension in the 2 ropes T1 and T2. Okay, let's draw a vector diagram for this one. Here we have W and here is T2, right? And here is our T1, right? And our system is in equilibrium, so they should have what? The same direction for its arrows, right? If it has a resultant force, right, if it has a resultant force, it should have the opposite direction for the arrow of the resultant, right? Like this, right? Here if it is A, here if it is B, if this is resultant. For A and B we have what? anti-clockwise direction, and for the resultant we have clockwise direction, right? And if we have a resultant, that resultant should have the opposite direction of other vectors, right? Here we don't have any resultant, so our vector should have what? Same direction, so the resultant will be 0. Why? Our system is in equilibrium, so w plus t1 plus t2 should be 0, because if you add all these vectors, right, here I'm adding w from here to here, right, and here it is t2 over here, and here it is t1, and we'll come to our starting point, which means we have no gap, it is 0. So that is what we represent from this equation if we don't have a resultant. So the answer is D, right? Here it's 10th one, I have done it. Here I will explain it, right? Here you have a 30 newtons force, so you can resolve it into two components, right, horizontal and vertical. Here we have 30 cos 40, and here we have 30 sin 40. And what is work done? Work done is force times distance into the direction of force, right? And they have given, right, the distance, it is 5 meters along the ground. So you can clearly see there is no distance into the direction of this 30 sin 40 force, right? We have only 5 meter distance for this 30 cos 40 force, right? Okay, if I calculate this one, it is equal w equals work done equals 30 cos 40 times 5 meters, right? Here it should be newtons. So if you simplify this one, you will get 114 point something, like 9 something. So the answer is B, right? Okay, here we have a photograph of rocket, and they say the rocket's engine give a total upward thrust of 7.3 10 to the power 7 newtons. Calculate the initial acceleration of the rocket. Mass of the rocket is 5 times 5.0 times 10 to the power 6 kilograms, right? Okay, if I draw a free body force diagram, here is our rocket, right, and this is our weight, and here is our what? Upward thrust, let's call it Fn. And according to F equals ma, our rocket will accelerate toward this direction, and we all know sigma F equals ma. What is this sigma F? Is the resultant force acting on the rocket, or we can take it by taking the vector sum of all the forces acting on the rocket. And they have given us only the mass, so we have to calculate what is weight. So W equals mg, so starting from here, mg, and mass is 5.0 times 10 to the power 6 kilograms times g is 9.81 newtons per kilogram, right, per kilogram. And if we simplify this one, you will get 4.91 times 10 to the power 7 newtons, right? Then we can apply what? F equals ma, right? This is the direction of the acceleration, so F equals ma, and F should be the vector sum of the forces acting on the rocket, the resultant. Then we will get the resultant, right? To take this vector sum, right, I'm going to take the vector sum of all the forces. So we have two forces, and forward thrust is acting towards the upward direction, so it is positive, and weight is opposite to that direction, so it is negative, because we all know vectors have directions and magnitudes, right? Then our thrust is 7.3 times 10 to the power 7 newtons minus a weight 4.91 times 10 to the power 7 newtons. If I explain it again, here this is positive, y it is acting towards this direction, and here this is negative, y it is acting towards this direction, opposite to that direction. So if we take the F, which we call the resultant force acting on the rocket, that will give us 2.39 times 10 to the power 7 newtons. Now we can apply F equals ma because we know the resultant force. Then 2.39 times 10 to the power 7 newtons equal the mass times acceleration. Mass is 5.0 times 10 to the power 6 kilograms times the acceleration. So you can take the acceleration. If you take the acceleration, you will get 4. If you simplify this one, 4.78 meters per square second. That is our acceleration. Right. So you will get marks for finding weight. Over here you can clearly see it is 3 marks. One is for that one, and one is for using F equals ma, finding vector sum, and for your final answer. Right. In the next one, here part B, they're asking give one reason why the acceleration will increase as the rocket rises. Right. You can clearly see our equation, and it is, this is the resultant force, or you can write it as upward thrust minus weight equals ma, sorry, right? So if this one is increasing, this one is decreasing, right? They say acceleration will increase. If this one is increasing, right, if this one is increasing, this one should decrease, right? We cannot increase this one because this is the upward thrust that we are giving, so weight should decrease. So is it possible? Right? Yes. The reason is the mass will decrease, or we can tell weight will decrease. Why? The fuel is used up while it is moving upward. That is the reason. So you can write the mass or weight, right, decreases. Why? Fuel is used up. Fuel is used up, right? Here in the 12th one, a teacher demonstrated the principle of conservation of the linear momentum using two gliders A and B and an air track. A has the same mass as B. A and B were initially stationary. Then A was pushed gently towards B as shown. Here the first question they're asking, state the principle of conservation of linear momentum, right? And here they have given 2 marks, right? I will explain why they have given 2 marks for this question. The first thing you have to mention that total momentum remains constant, or you can tell it like total momentum remains constant, or you can momentum before a collision, total momentum before a collision, for the collision is equal to total momentum after the collision, right? If you write this point, you will get only 1 mark. You have to explain one more thing. What? When there is no external forces, right? When there is no external, or you can write resultant over here. Resultant, either resultant or external, you will get the mark. No external force acts on the system, right? So if you have like this one, you will get the other mark, right? Always keep this in your mind. What when they ask you to state the principle of conservation of linear momentum, you had write these 2 points. But the first one is total momentum before a collision is equal to total momentum after collision when there is no external or resultant force, or you can mention if the system is a closed one, right? In the part B, a magnet was attached to each glider, right? The glider collided and stuck together. A data logger sensor was used to record the velocity of A. The velocity recorded after the collision was half the velocity recorded before the collision. Deduce whether these results show that the law of conservation of linear momentum is obeyed, right? Here this is our system before the collision, and here is glider A, right? And here is glider B, and suppose this one has mass m, this one has mass m, and if this one is moving with a velocity of 2v, right, momentum before the collision of the system is, right, 2 times mv. Why? This one is stationary, so it has no momentum, right? So after the collision, when they stuck together, right, they have mentioned what the velocity is now halved, so it is just v, but the mass is doubled, so the momentum is 2 times mv, so momentum remains constant, right? And there is no external forces, right? Then you have to mention this one in 2 points. How? First one, you have to mention that momentum is mass times velocity, and after the collision the mass is double. Mass is doubled, right? Then even if mass is doubled, our velocity is now halved, right? So momentum remains the same, so you have to mention that one, right? But velocity is half its original value. Therefore momentum remains the same. Remains the same. So the law is obeyed, right? Keep in your mind what when they have mentioned you, there are 2 marks, so you have write 2 points, so 1 mark for this one and the other mark for this one, right? The next one, explain why the force of attraction between the 2 magnets did not affect this demonstration, right? Here's our glider A and here's our glider B, right? Here they have mentioned force of attraction, so we will have force over here, and you should know one, these 2 forces are Newton's third law forces, so they have the equal magnitude and opposite direction. So what will happen, due to this force, our mass or the glider A will accelerate towards this direction, and due to this force, due to this force, our glider B will accelerate towards this direction. So they will have equal and opposite accelerations. So they will cancel out, right? Or we can conclude we don't have any resultant forces acting on the system. Why? These two forces are equal and opposite, right? Even here they have mentioned it is 2 points, so we had to explain our answer in 2 points, right? Can mention that the gliders accelerate in opposite directions, opposite directions, right? Why? The magnetic forces are equal in size and opposite in direction. Forces are equal in size and opposite in direction, right? Then you can mention, so the resultant force on the system is 0. So the resultant force on the system is 0, right? 13th one. Here tennis players can practice using a tennis ball machine. The machine projects tennis balls horizontally from a height of 2.5 meters as shown, right? Here's the tennis ball machine. Here they're asking us to show that the time taken for a ball to reach the ground is 0.7 seconds, right? What do we know from this information? And we know the displacement, I mean the vertical displacement, and here it has 0 vertical velocity, and we don't know what is its horizontal velocity. And this one is 0, and we don't know what is its horizontal velocity. We don't know it, right? And we know acceleration, and we know yeah, that's what we know. So we know S, the vertical one, and the acceleration vertical one, and U, right? And they're asking T. So what is the equation that we should substitute our values? It is S equals ut plus half at square, and the direction is this one, direction of the acceleration, right? So here it is 2.54 meters, and our u is 0, so we don't need to consider this one. Half times acceleration, it is 9.81 times meters per square seconds times t square. So if you simplify this one, you will get your t 0.72 seconds, right? 2 marks are given for using this equation, substituting your values, and for the final answer, right? Here in the second one, the ball lands on the ground at a horizontal distance of 17.89 from the machine. Calculate the velocity of the ball as it is projected from the machine, right? Now we know what this length, or we call the displacement, horizontal displacement, and we want to find this one, and we know t, so we can use s equals ut, because we don't have any acceleration towards horizontal direction, no acceleration, right? So I'm going to use this equation, s equals ut, and we are using it to horizontal direction, and s, here they have given it 17.89 meters equals u times t. We don't know u, which means horizontal velocity, times t, it is 0.72 seconds. So if you simplify this you will get what? You will get 24 point here you will get UH 24.8 meters per second. So if we make it into correct significant figures, it is 25 meters per second, right? Two significant figures, right? Here B, the initial velocity of the ball as it is projected from the machine can be increased. Explain how increasing the initial velocity would affect the angle at which the ball hits the ground, right? Then let's draw the path of the ball right here, and here's our ground, and if there is no ground, ball will move like this, right? Then we all know what it has a vertical velocity, the final vertical velocity, let's call it v vertical, and here is its vertical horizontal, final horizontal velocity. So if we increase, right, if we increase what? Initial velocity, here you can clearly see the initial vertical velocity is 0. Initial vertical velocity is 0, so we cannot increase that velocity, but we can increase what? Initial horizontal velocity, right? Then what will happen? This v will remain as a constant, right? We cannot do anything about vertical velocity, but we can increase what? VH. Then if you make it into correct vector diagram, so here it is VH, here this is VV, then we can have the angle over here. So our tan theta is equal to VV over VH. So if we increase this VH, what will happen to our theta? Theta will decrease, but we have to write it in terms of 3 points, right? How can we write that down? First thing, you have to mention that if you increase your initial velocity, then what will happen to our final horizontal velocity will increase. How? Because the initial vertical velocity is increasing, so you have to mention that one, right? If the initial velocity is increased, the horizontal component of velocity is larger, right? Next point is, right, the vertical component of velocity as ball hits the ground is not affected because we cannot do anything regarding vertical velocity, right? The vertical component of velocity as the ball hits the ground is not affected. So we have to explain what happens to our theta. Then you have to mention, right, when theta is the angle to the horizontal, we have taken this one as our theta, right? When theta is the angle to the horizontal, what happened? Tan theta equals VV over VH, right? So theta decreases. so theta decreases. Right. Here, a student exercises by lifting weights attached to a machine. The machine has a cable as shown in the photograph. The cable passes through a handle and is connected to a weight. Right. There is a tension T in the cable. The angle between two sides of the cable is 60 degrees as shown in the diagram. A person keeps the cable stationary by applying a force F of 121 newtons. Determine the magnitude of the tension T in the cable using the scalar vector diagram. Right. Okay. Then here we have the force of T, and here also we have the force of T, and the person is applying force of F, right, between two sides. So our force of F be like this. We draw it, then you can clearly see here the angle is 30 and here angle is 30, right, and here angle will be 60 because here also 60 and here also 60. Then here the angle will be 120, right? So what I'm going to do here, I'm going to take this side as my horizontal side, right? So if I draw it over here, right, this is my T, and you don't know what is T, just select some random length more than 6 meters, because there's a minimum length that you can take for a vector. So they have given 1 mark over here, it is 4 marks. So to taking a length more than 6 centimeters, you will get 1 mark. So here's our T, right, which means this one, this T I have drawn, and you can clearly see what here our this T, this one creates an angle of 60 degrees with this T, creates an angle of 60 degrees with this T. So I'm going to draw my second T with a 60 degrees and with same length, right? So if I have taken it's 8 centimeters, this one also should be 8 centimeters. For the sake of argument, just assume I'm taking it as 6 centimeters, and this one also should be 6 centimeters, and this angle should be 60. Why? Here we have 60 degree angle over here, right? Here we have 60 degree with this T, right? This T is creating a 60 degree angle with this T, so it is 60, right? Then if we connect these two, right, and our system is in equilibrium, it is not moving, so it has no resultant force, and our force F should come to its initial position like this. Oh, right. And there's another thing, before you're going to draw this one, you have to check what angle over here. How can we check that angle, right? Here, right, you have to take what is the angle, right, what is the angle that our force F, is creating with what, is creating with this T, which means this one. This is the angle of our force F creating with this T. So if I make it a little longer, we all know this angle, it is 30. Then here also angle should be 30 according to geometry. So our this angle should be 30 degrees. Then our force come back to this position, and this is our F, right? Arrow should be like this. So if our T is 6 centimeters and here also 6 centimeters, then now you have to measure your force of F, right? If you have taken it as like 12 centimeters or something, right? If your force of length of the this force F is 12 centimeters, then it is 121, right? I don't know if it is 12 or whatever, I just assume it is 12. Then by taking the ratio to 1 centimeter, right, if this is right? If this is 12 centimeters and our force F represents 121 newtons, so from 1 centimeter we can take 120 over 12 centimeters, right? You will get the value of force represented by 1 centimeter. Then you have to measure this t. No, you don't need to measure it, we have taken it, right? So you can just multiply your length, that if it is 6 centimeters, you have to mention we have 6 centimeters, this is for 1 centimeter, 121 over 12 centimeters, then you will get the answer, right? The T should be in between 65 newtons and 75 newtons, right? Here the cable is attached to 150 weight. Each time the person pulls the handle, the weight moves up a vertical distance of 0.25 meters. The weight returns to its original position when the handle is released. The person exercises by pulling and releasing the handle. They do this 9 times in 120 seconds. The exercise machine displays the average power of the person as 35 volts. Deduce whether the power displayed by the machine is consistent with the data, right? We all know what our change in energy, which we call work done, is equal to force times delta S, right? Here we have 150 newtons and the distance is 0.25. So if I take our change in energy, which we call work done, it is 150 newtons times 0.25 meters is equal to 37.5 joules, right? He has to he has to consume his 37.5 joules for do that work, and he is doing it 90 times in 120 seconds. So you can find the power, right? The power is equal to what? Work done over time. So our work done is 37.5 joules and he is doing it 90 times within 120 seconds. So 90 times 120 seconds, so you will get the power as 28.1 volt. Then it is not 35, here it is not 35, right? Here it is 28.1. Then we have to write our conclusion 1, right? P is equal to 28 watts, which is not equal to 28 watt, which is not 35 watt, so it is not consistent. So it is not consistent. Okay, in the 15th one, photograph shows a ladder that a person can use to climb into the roof space of a building, and here's the front view, and here they have given a side view. When not in use, the ladder is stored in the roof space and the opening to the roof space is covered by a board. The board is hinged to the ceiling at one end. The ladder is attached to the board by a rail as shown below. A small block prevents the board from rotating into the roof space, right? State what is mean by center of gravity of an object. Here you have to mention that what point through which weight may be taken to act. Weight may be taken to act, right? Point through which weight may be taken to act, right? You have to mention this one, what weight may be taken to act. Right. Here, the weight of the board and rail is 50 newtons. The weight acts at a distance of 0.45 meters from the hinge as shown. The total length of the ladder is 2.70 meters with 0.85 to the left of the hinge. Right. And here they have given the weight of the board and rails is 50 over here, right, and the weight of the ladder is 54, right. Assume that ladder is uniform. Explain why the board and ladder remain in the position shown, right. So if I just assume that the center of gravity of the ladder is here, right, our 54 newtons is acting from here, and this is our hinge, and this is our block, right. This is our block. Here we had block right here, right. Then we have to take moments around the hinge. Before that, we have to find the distance here, which means center of gravity of distance from hinge to center of gravity of ladder, and they have given the ladder is 2.70 meters, which means this distance here, right, this one, right, I will make it more clear, right. Center of gravity, we have taken it at this position, and it is the distance from here to here is what, 2.70 over 2, right. The whole length of the ladder is 2.70, and the length from one end to its center of gravity is 2.70 over 2. To find this one, let's call it x, or determine the distance from hinge to center of gravity of ladder, right. This x will be what, equal 2.70 over 2 minus this 0.85 meters, right. This is the distance from hinge to center of gravity of ladder, right. And I'm going to write that one, because here they have given 5 marks for this question, so it is sensitive more than you think. Distance from hinge to center of gravity of ladder, right. Center of gravity of ladder. So it is we call it x, whatever you prefer, you can call it 2.70 over 2 meters minus 0.85 meters. So that will give you a value. I will calculate and tell you 1.35 minus 0.85. See, 2.70 by 2, 1.35 minus 0.85, so it is 0.5, so it is 0.5 meters, and we know what this distance, which we call x, is now 0.5 meters, and we have to find its moment around the hinge, right. Let's find it, right. Clockwise moment, and that is equal to 54 newtons. Here the force is 54, right, times 0.5 meters, and that is equal to 27 Newton meters. Then the anticlockwise moment is equal to 50 newtons times 0.45 meters, right? How? Here they have given it is 0.45 and the weight of the board and the rails is 50 newtons. So if you take this one, you will get 22.5 Newton meters. So you can clearly see our anticlockwise moment and clockwise moment are two different values, so they are not equal, right? So you have to mention that one, what the clockwise moment, right? Clockwise moment is greater than anticlockwise moment. Anticlockwise moment. Then how is it possible to remain in this position, right? Clockwise moment is greater than anticlockwise, right? Here says this clockwise moment is greater than this anticlockwise moment, so it should have another force, right? Another force which will cause to have an anticlockwise moment. So block is giving a contact force here, and that force is giving what? An anticlockwise moment. So that is why our board and ladder remains in this position, right? You have to mention that one, right? Here the block causes a force, block causes a force, right? So the resultant moment is 0. That is why our system is now in equilibrium, right? In the part 2, they're asking a downward force is required to rotate the board away from the block. This force is applied 0.80 meters from the hinge, right? Determine the magnitude of the force, right? If I draw a diagram to visualize this scenario, right? Here is our hinge and we have a force over here which is causing for our clockwise moment, and here's another force which is causing an anti-clockwise moment. Then our system is trying to move towards this direction because our clockwise moment is greater than anti-clockwise moment, so it is trying to move towards this direction. So if we can supply a force, right? If we can supply a force from 0.80 meters, let's assume this is 0.80 meters, right? Might be somewhere over here, we don't know exact point. It is 0.8 meters, they say, right? Then what will happen, right? Our board is movable towards down, right? If you can supply this force. So what will happen if we can supply a force from 0.80 meters from the hinge, right? That force will balance the whole system and make it possible to move down, right? Okay, how can we calculate this one? It is really simple, right? First we have to take the resultant moment, right? It is equal to 27 Newton meters minus 22.5 Newton meters, right? So it will have a resultant clockwise moment of 4.5 Newton meters. By giving this downward force from 0.80 meters from the hinge, we should balance this resultant moment, right? It is a clockwise moment over here and by giving this force we are giving anti-clockwise moment exactly equal to this value, right? They are asking this force. So F times 0.80 meters equal to 4.5 Newton meters. So our force will be what? If we simplify this one, is 5.63 newtons, and it is 5.6 newtons, right? Right. In the next question, here they say a steel object is held by an electromagnet. The magnetic force prevents the steel object falling. State two reasons why the weight of the object and the force from the electromagnet are not a Newton third law pair. Right. Here's our diagram that they have given. You don't need to even look at this diagram to write the answer for this question, right? First you have to can write they are not same type of forces. They are not same type of forces. They should be same type of forces to be a Newton's third law pair, right? And you should mention that, right, they both act on same object, right? They act on same object, right? Here the weight and the what magnetic force, right? Here the weight also act on this object from the center of gravity, and here the electromagnet is attracting this object from here, so they both act on the same object, right? Here in this part B, the electromagnet is suspended from a support by a steel cable as shown, right? When the object is suspended, the strain in the cable is 3.0 times 10 to the power minus 4. Calculate the Young modulus of the steel in the cable, right? Cross-sectional area of cable equals 5.1 times 10 to the power minus 4 square meters. Unstretched length of cable equals 3.8 meters. Stiffness of cable is equal to 2.8 times 10 to the power 7 Newton per meter, right? Let's calculate what the Young modulus, right? I think you know the equation. You can check it from the equation sheet, and Young modulus equals F over A stress over strain, right? Here this is stress, I will write it over here, over strain, and here it is x over delta x, right? Then here they have mentioned what strain, so strain is equal to what, x over delta x, right? Then if we know the unstretched length, which means it is x, and if we know the strain, so we can find delta x, which is extension. So our delta x is equal to what, strain times 3.0 times 10 to the power minus 4 times 3.8 meter. So our extension is what, if you simplify this one, you will get 1.14 times 10 to the power minus 3 meters, right? Then we can find the force by using F equals kx, and here they have given our stiffness of the cable, and it is what we call k, spring constant, and F is equal to stiffness of cable is 2.8 times 10 to the power 7 Newton per meter, right, times the extension 1.14 times 10 to the power minus 3 meters, right? Then our F is equal to, if we simplify this one, you will get 3.19 times 10 to the power 4 newtons, 3.19 times 10 to the power 4 newtons, right? Then we can find out what, because they have given the cross-sectional area, right? So we can find stress is equal to F over A. Now we know F, it is 3.19 times 10 to the power 4 newtons over what? 5.1 times 10 to the power minus 4 square meters, right? So if you simplify this one, you will get the stress. It is 6.26 times 10 to the power 7 pascals. And I have mentioned, but Young modulus is equal to stress over strain, and we know both now. Stress is 6.26 times 10 to the power 7 pascals, and our strain is they have given it is 3.0 times 10 to the power minus 4. So if you simplify this one, you will get what? 2.09 times 10 to the power 11 pascal, right? So you can write it over here, 2.1 times 10 to the power 11 pascals, right? Here the force extension graph of the steel cable is shown, right? Total weight of the electromagnet and steel object on the y-axis, the force, and here we have extension on the x-axis. When the electromagnet is switched off, the steel object falls. A student states that the change in elastic strain energy stored in the cable will be transferred to the gravitational potential energy of the electromagnet. Discuss the student's statement. You should add to the force extension graph as part of your discussion, right? Here is our electromagnet and object, right? Oh wait, right, yes, our electromagnet and object. Here is our object, and if you switch it off, what happened, right? This object will start to move down because there is no magnetic attraction. If we switch off it, then what will happen? Due to its less weight, now our electromagnet will move upward, right, with some kind of distance, and we don't know it, right? Then here the elastic strain energy of the wire is total weight of the electromagnet and steel object, right? Here we have total weight because here is our electromagnet and here is our object, steel object. So if we switch it off, what happened? The steel object will fall, then only we have what? Electromagnet, right? So I'm going to draw it now. The new force acting on this cable, right? Let's call it Ft, and this is Fn, right? Fn will be somewhere here. This is Fn, and right, this is Fn, and what happened to its extension? Its extension will decrease, right? Let's call it delta x, right? So this is our delta x, right? So if I ask you, what is the change in GPE? I mean, what is the change in gravitational potential energy over here, right? Okay, now our electromagnet has moved its position with a distance of delta x, right? So if I want to take it, it is the new force over here, right, which will cause mg of this one, right? Fn means mg. M means the mass of the electromagnet, and let's call it weight, right, times delta x, which means our GPE, or which we call change in GPE, will be equal to mg times delta x, because it is h. We all know GPE is mgh. So you can clearly see what our change in GPE is, what? Fn, new force, times new tension times what? Delta x, right? So how can we represent that one? from our graph, right? So here it is Fn and here our delta x. So here we will get our what? Here we will get our change in GPE, right? This is what we call change in GPE. Right, delta GPE. Then what is this whole area? I mean, now the rectangular shape is change in GPE, okay, right? Rectangular one is change in GPE, but what is this whole? It is the elastic strain energy, right? Right, this elastic strain energy that gives out by decreasing its weight, right? This elastic strain energy, I mean, they were right here, right? Because we all know W equals what? W equals half times F delta x, right? Half times delta x. Half times delta F means here they are taking half times F. Here they are taking the average force. Why? Because our force is moving from Fn to the total, right? So our force is decreasing, right? That is why we are taking half times F to take the average, right? Fn plus the total over 2. That's what we call half times F, right? Work done. And that is the elastic strain energy, change in elastic strain energy, right? So it was overhaul this portion in the previous. Now it has come to this rectangular shape plus triangular shape, and that is the change in elastic strain energy, right? And what is this rectangular shape? Only it is change in gravitational potential energy. Got it? I hope you understand. If I explain it again, what this rectangular shape plus triangular shape is the change in what? Elastic strain energy by that is equal to W equals half times F delta x. Why we are taking half times F? Because we want an average force, because our force is decreasing, right? Then change in GPE is equal to the rectangular area of the rectangular shape. Why? It is mgh. Mg is, we all know, the new force, the force weight of the electromagnet over here, right? That is mg equals Fn. Then times delta x is the increased height or the decreased extension, so it is GPE, right? How we can write this one, right? That is the whole point here. Now I'm going to write this one. The first thing you have to mention what, right? Area under graph is elastic strain energy, right? I hope you remember this one, right? Area under graph is equal to elastic strain energy, right? Then the next point, still after this, after we have switched off this one, still its weight of the electromagnet is acting on the wire, right? So you have to mention that one. Weight of electromagnet is still exerted on cable after object falls. after object falls, right? Then you can write what so change in elastic strain energy is equal to area under graph between total weight and weight of electromagnet, right? Means the rectangular shape plus triangular shape, right? Change in elastic strain energy, change in I'll write it like this way. Elastic strain energy, right, is equal to area under graph between area under graph between total weight and weight of electromagnet, right? Means this whole area, right? This whole area, right? Because it is W equals half times Fx, which gives us the area of this trapezium, and we are taking half F to take the average force, because force is decreasing from total weight of electromagnet and steel object to just weight of the electromagnet, right? Next point, one, right? Change in gravitational potential energy of electromagnet, right, is weight of electromagnet times the change in extension. I have explained this over here. I will write over here and explain it again, right? And change in gravitational potential energy of electromagnet is weight of electromagnet times what? Change in extension, right? Here I have mentioned that one. The change in GPE is mgh, and that is equal to mg times delta x. Delta x is the change in position, right? So it is F times delta x. So it is the area under this what? Rectangular shape. Last one, you have to mention what? Our change in elastic strain energy stored is greater than change in gravitational potential energy of the electromagnet, right? So change, I will write it over. Why, you can clearly see, I hope you can see this whole area is greater than just the area of rectangular shape, so it is obvious. So you have to mention that one, right? So the change in elastic strain energy stored, change in elastic strain energy stored is greater than what? Change in gravitational potential energy. Change in, I write it as GPE, energy of the electromagnet. right. Right. Here in the 17th one, scientists used weather balloons to carry equipment into the upper atmosphere to monitor weather conditions. The photograph shows a weather balloon. Upthrust acts on the balloon. The balloon is released and accelerates upwards. State what is mean by upthrust. So you have to mention. Here we have 1 mark for this one. An upward force, upward force, um, upward force caused by what? Caused by displacement of the fluid. Of fluid, or you can mention it like a force equal and opposite to the weight of the fluid displayed. You can mention it like that. You will get 1 mark. In the part B, when the balloon is released, the initial upward acceleration is 4.80 meters per square seconds. Show that the weight of the balloon and equipment is about 13 newtons. Here they have given volume of the balloon and equipment 1.63 times 63 cubic meters, and density of the air at ground level 1.23 kilograms per cubic meter. So what we are going to do over here, we need to calculate upthrust first. If I draw a free body force diagram, here's our balloon and this is our upward force and this is its weight, right? Here it is weight and here it's upward force and the balloon is accelerating, right? So I need to calculate upward force. It is equal to V rho G, and V is the volume over here, and they have given it 1.63 cubic meters, and the density they have given 1.23 kilograms per cubic meter, and the gravitational acceleration they have given it 9.81 newtons per kilogram, right? So if you calculate this one, you will get your upward force as 19.67 newtons. Now what we are going to do, we know the sigma f, or resultant force acting on the balloon, is equal to mass times acceleration according to Newton's second law. So we need to calculate the resultant force. Our resultant force is equal to upward force minus weight. Why? Our upward force is acting this direction, and it is, if we have taken it positive, and this one should be negative, and our equation also we are applying to the upward direction, right? So it is 19.67 newtons minus the weight they have given it. Have they given it? No, we don't know weight, right? So it will be mass times the gravitational acceleration. It is 9.81 newtons per kilogram, right? This is the resultant force, and we can write it, we all know sigma f equals ma, so we can write it like this, 19.67 newtons minus m times 9.81 newtons per kilogram equals to mass times its acceleration. So mass times, they have given the acceleration, it is 4.80 meters per square second, and they're asking the weight. They're asking weight, so we don't need to write it like this. We can directly write W bar, but we can't do that because we don't know the mass. We have to find mass first, then we have to apply W equals mg. Here it is m times 9.81 newtons per kilogram. So if we subject m from this equation, it is 19.67, right? Or you can take it as 19.7, right? Over 9.81 plus 4.80, right? 4.80, here it is newtons and here it is newtons per kilogram. So if you simplify this one, you will get 1.346 kilograms. Then you can apply W equals mg, so you got the weight, right? Here they have substituted 7. No, if it is okay if you have 7, substitute 6 7, right? 0.7, so you will get your weight as 13.20 newtons, and here they have asked us to show that it is about 13 newtons, right? The graph shows how the density of air decreases with height above the ground. So the scientists want to make measurements at a height of 25 kilometers where the balloon would stop rising. The balloon will expand as it rises and will burst if its volume exceeds 50 cubic meters. It is whether the balloon could support the equipment at a height of 25 kilometers without bursting, right? Then we need to find out the density where the balloon is at 25 kilometers height. So here I have to measure this value over here, right? They have given marks to finding that value, and your range of that value should be in between 0.040 kilograms per cubic meter and 0.05 kilograms per cubic meter, right? You can easily get it. How? Just here it is 20, and we have if we 1 2 3, so it is 1 2 3 4 5. So if you divide from 5, you will get 0.040 kilograms per cubic meter, and your value should be in between this range, right? Okay, I'm going to find out the answer. First, what we should do here is we have to take our thrust 13.2 and find its volume, right? So I'm doing that one, v rho g, and our thrust is 13.2. We require 13.2 newtons. Thrust to accelerate it with 4 point something, 4.80 meters per square seconds. And we don't know v, right? Because it is expanding right here, so we have to find v, and rho we got it 0.0. You can substitute a value between this one, so I'm going to substitute 0.05, right? You can either substitute 0.040, doesn't matter, right? Kilograms per cubic meter, this rho, times the gravitational acceleration, and it is 9.81 newtons per kilogram. So if you simplify this one, you will get what, 26.9 cubic meters. So here you can conclude what volume does not exceed the value of 50 cubic meters, so it does not it will not burst, right? So 26.9 cubic meters is less than 50 cubic meters, right? So you can mention that we have no issue, right? So yes, it will support, right? In the next one, a weather balloon made of a strong material will rise, eventually stop expanding. It will continue to rise until it reaches a maximum height. Explain how and why the velocity of the weather balloons changes from release until it reaches the maximum height. Ignore the effects of viscous drag. Here they have given 6 marks, and you should know this is a synoptic question, so you have to mention your 6 points in the correct logical order. Keep that in your mind, right? First thing you have to mention, right, we all know, right, upthrust minus weight equals ma, right? In the I mean at the beginning we all know upthrust is greater and greater than weight, then our resultant force is upward. We have to mention that one. What when the balloon is released, when the balloon is released, upthrust is greater than weight, right? So our resultant force is upward, right? So force upward, right? Then if our resultant force is upward, what happen? Our balloon will accelerate, right? Here the acceleration, so velocity is increasing, right? So velocity of balloon increases, right? Then what happen when the balloon is at its maximum volume? Then what will happen? So not the maximum. When the balloon is accelerating, its velocity is increasing and its position also increasing. And according to our graph that they have given, we all know what happened to its density. Density is decreasing, right? Density is decreasing. So what will happen to our upthrust? Upthrust is decreasing. Why? It is v rho g. If rho is decreasing, upthrust also decreasing, right? So you have to mention that one. Upthrust decreases, upthrust decreases as height increases, right? So what will happen to its acceleration? That acceleration also decreases, which means the rate of change of velocity also decreasing. Then at some point what will happen? Upthrust will be less than weight, so the resultant force is downward. At some point what will happen? This one is decreasing, so at some point our weight will be larger than upthrust, so the resultant force is downward, so its velocity starts to decrease. You have to mention that. How can we write that down here, right? Until upthrust is less, until upthrust is less than weight, uh, upthrust is less than weight, a balloon uh, will accelerate, will accelerate, right? But after some height, after some height, what will happen? Uh, weight will be greater than upthrust. Weight will be greater than upthrust. So the resultant force. So the resultant force is downwards. Then what happen? Its velocity will uh, decrease, so we can tell balloon then start to decelerate to rest, right? Balloon then decelerates decelerates to rest side. So my opinion, when you're writing a synoptic question, just try to understand what's going on with the scenario, then write like a paragraph with the details as much as you can, and place it in a correct logical order, right? If you can understand the concept or the scenario going on with a correct concept, with the correct concepts of physics, right, probably you can write with a correct logical order, so you can write it. So my uh, opinion is, please try to handle this type of questions with a paragraph form, and try to write as much as details you can with the correct logical order, then you will get the 6 points. Otherwise, here I have mentioned just 6 points what you have to write in this question, what they expect from you. I have just wrote these points. But when you're writing this kind of question, my opinion is, follow a paragraph type and write as much as details you can with the correct logical order. For that, you have to understand the situation with accurate concepts, or with the help of accurate physics concepts, right? Right, 18th one, right? Student carried out an experiment using a data logger to record the motion of a ball bearing as it fell through a liquid. State the conditions under which Stokes law applied to an object moving through a fluid, right? The object should be small spherical object, or you can mention that spherical object moving at low speed, uh, and you had to mention here 1 mark for this one, small spherical object or spherical object moving at low speed. Next mark is given to mentioning that the flow should be a laminar flow or non-turbulent. The flow should be a laminar flow, right? Or you can mention non-turbulent flow right here. The graph obtained by the student is given below. Here you can clearly see, right, the velocity at the beginning is 0 because the gradient is 0. Then after some time, right, our object has reached its terminal velocity. That is why we are having a what we call constant gradient throughout this graph, right? Explain the shape of the graph, and here they have given 3 marks for the question, right? So you have to point out 3 points, right? So you have to mention, you can mention first one, what the initial speed is, 0, initial velocity is 0. Initially the velocity is 0. Why? The gradient is 0, right? Gradient is 0, right? Here you can clearly see, right, gradient is 0, right? Next point, uh, as velocity increases, what happens? The gradient changes, right? And you all know the drag also start to increase because drag is equal to 6 pi eta rv. So if the velocity is increasing, drag also increasing, right? As velocity increases, drag increases. Velocity increases, drag increases, drag increases, right? Then after terminal velocity, what happened? The gradient becomes constant, right? Right. When it has reached the terminal velocity, the gradient becomes constant, right? when it has reached terminal velocity, the gradient becomes constant. Right here they have given 3 marks, but I wrote 3 points. These are the points that they expect from the marking scheme. If you have right any of these 3 points, you will get 3 marks. Any of these, any of any 3 from these 4 points, any 3 from these 4 points, you will get 3 marks. Right here the ball bearing had a diameter of 1.6 millimeters. The difference between the upthrust on the ball bearing and the weight of the ball bearing is 1.45 times 10 to the power minus 4 newtons. Calculate the viscosity of the liquid. Assume that Stokes law applies. Right. How can we do this one? First, we have to find the radius because to find the drag force we need radius. So the radius is equal to 1.6 millimeters. So I'm going to convert it into meters. Right, you have to convert it into meters, right, to get your values in correct SI units over 2. Then you will get 8 times 10 to the power minus 4 meters. Then you have to find gradient for what? To find the terminal velocity, right? You have to find the gradient from this graph, and when you have to find gradient from the graph, right, just take 2 points you prefer, then calculate delta y over delta x. It is what we call a gradient. I'm not going to calculate that one. I'm going to use the value they have given. I think you can do it, right? So the gradient, right here they have the gradient, right? You have to mention how you got it, like 11.5 over 1 point, right? These values will differ if you have taken 2 other values, but the gradient should be equal, right? 0, yeah, it should be 20.9, right? But you don't need to worry if your value just differs from a small amount, because here they're expecting our answer in a region between 2 numbers. So if your answer is in between that region, you don't need to worry about that one. You just need to make your measurement or make your calculation accurate as much as possible, right? So here it is 20.9 and the velocity will be equal to what? 0.209 meters per second. Why? You will ask why, right? Just look at the graph. Here they have given the displacement in centimeters, so you better go with this y-axis by converting it into meters, right? Here just took the answer that they have given, so just need to multiply it from 10 to the power minus 2, then you will get it in meters per second. So what I have done here, then if you know this one, what you can do is, right, they are asking us to calculate the viscosity. So here they have given the difference between the upthrust and the ball bearing. The weight of the ball bearing is 1.45, which means it is the drag force, because these 2 forces should be equal, right? The drag force, right, and the weight should be equal to reach terminal velocity. So I'm going to use weight instead of this drag force because these 2 forces are equal. So it is 1.45 times 10 to the power minus 4 newtons, and it is equal to 6.5 r eta v equals 6.5, and we know now r, it is 8 times 10 to the power minus 4 meters eta times v, we have taken it, it is 0.209 meters per second. So you have to simplify your answer, then you will get it as 0.0460 Pascal seconds, right? This 0.046, but you don't need to worry about if your answer is just differ from this answer with a very little amount, because your answer should be in between 0.044 and 0.048, because your gradient, as I told you, can be vary from very little amount from this 20.9. I have taken the exact value they have given in the marking scheme, right? In the third one, the student heated the liquid and repeated the experiment. The ball bearing took less time to fall a given distance in the liquid when the liquid was at a higher temperature. Explain why. Assume the density of the liquid is constant, right? We all know what happened when the temperature increased to its viscosity, right? Viscosity will be decreased, so the coefficient of viscosity will be decreased. So you have to mention that one first. But at higher temperature, the viscosity will be less. Then our stocks 65 r eta v, all the other values, sorry, here 65 is constant, r also constant, and if this one is decreased, right, this one is decreased, so our drag force should be equal to weight. Our drag force should be equal to weight, and weight does not change. They have given the weight, what is the weight that they have given? 1.45, right? It is 1.45 times 10 to the power minus 4 newtons. Over here 65 r eta times v, right? We have to balance the exact value that we have balanced previously. So if these three values are constant, if our the coefficient of viscosity is decreasing, terminal velocity should be increased, right? Otherwise we can't balance it. That's why our time for second experiment is less than the first one, previous one. So how do you write this one? First you have to write down what F equals 6 pi r eta v, and r is constant. So drag force is less, right, at a given speed. Or you can mention that it's better if you can write drag force r is constant, so drag force is unchanged. We cannot change it because the drag and weight should be equal to reach the terminal velocity. So drag is unchanged, right? The last point is terminal velocity is greater, so terminal velocity is greater. So terminal velocity, right, terminal velocity is greater du2 plus, right? When you're writing this kind of a question, right, here first try to understand the concept with physics more accurately. Here I have explained that one. Then the next point is how we can write our answer in terms of the points that they expect from us, right? Okay.